Welcome, everyone. Today, we are going to unlock the data analyst inside you. You generate and interact with data every single day. We will learn how to upload CSV files into Claude to instantly identify trends, averages, and anomalies in your personal or business data. Let's get started. Let's kick things off by defining AI-assisted data analysis. What we're doing is using Claude as a collaborative analytical partner to process raw CSV data. The basics are simple. Instead of writing complex spreadsheet formulas, you upload your data and ask questions in plain English. Why does this matter? Because raw data is overwhelming, and our brains process visual narratives much faster. Claude's superpower is pattern recognition. When you feed it a dataset, it doesn't just read numbers. It looks for frequency patterns, cost correlations, and external factors. In our deep dive, we realize that Claude does the heavy computational lifting, but you provide the domain expertise to make the final decisions. Take a look at this flowchart. On the left, we start with your raw CSV data, the chaotic numbers you export from your systems. You pass this into the Claude pattern recognition node. Here, the AI acts as a filter, shifting into statistical analysis and synthesis. Finally, the output flows into your hands to make actionable business decisions. The AI handles the processing, but you remain in control of the outcome. How does Claude actually analyze a spreadsheet? It's important to understand the mechanics. We use the Files API and the Code execution tool. The basics are, you upload a CSV, and Claude writes code to analyze it. Why is this revolutionary? Because AI models are historically bad at doing math purely in their heads. By utilizing a secure code execution sandbox, Claude writes actual Python code to guarantee mathematical accuracy. For our deep dive, know that when you ask for an average, Claude is quietly importing the pandas library, loading your CSV into a date frame, and running functions like df.describe to get perfect statistical measures. You never have to see the code, but it's there ensuring your answers are rock solid. This sequence diagram maps the exact life cycle of your data. The user uploads a CSV and prompts Claude. Claude doesn't just guess the answer, it sends a programmatic request to a secure Python sandbox, executing real data science code like importing pandas. The sandbox returns the mathematical truth, which Claude then translates back into plain English insights for you. It is a seamless loop of accuracy. Before we find the magic insights, we must perform a data quality assessment. The what is a systematic review of your CSV. The basics dictate that before you ask for a trend, you ask Claude to find missing values or extreme outliers. Why? Because making business decisions on flawed data is dangerous. We have a saying, garbage in, garbage out. How do we do this? Simply prompt, assess the quality of this dataset and flag anomalies. For our deep dive, understand that Claude can use its Python tools to run df.isnull.sum. It can detect if your missing data follows a pattern, like maybe your system goes offline every Sunday, and it can clean that data by filling in median values before the real analysis begins. Observe this decision tree. When your raw CSV upload hits the Claude quality check node, the workflow branches. If it detects missing values, it routes to a node to impute or flag them. If it finds extreme outliers, it pauses to ask you to verify their accuracy. Only after the data passes these filtration paths does it reach the green node. Proceed to analysis. This guarantees a clean foundation. Now we start the actual analysis by finding the baseline. This means establishing the normal behavior within your data. The basics involve having Claude calculate averages and frequencies, like figuring out your typical monthly grocery spend or website traffic. Why start here? Because you cannot spot an anomaly if you don't know what normal looks like. How do you do it? You explicitly ask Claude for the mean and median of specific columns. Our deep dive reveals that averages can be deceptive if lumped together. Claude allows you to instantly segment these baselines. For example, comparing your weekday workout frequency against your weekend frequency, which instantly reveals context that a single flat average would completely hide. This flowchart shows the baseline process. The clean dataset enters the descriptive statistics engine. It splits into calculating mathematical averages and categorical frequencies. These calculations establish your baseline normal and identify dominant categories. They merge at the bottom, indicating that only now are we statistically ready for trend detection. With our baseline set, we move to spotting trends and anomalies. A trend is a directional movement over time, while an anomaly is a sudden, sharp deviation from your baseline. The basics involve looking at time series data, like a massive, unexpected spike in your December utility bill. Why do we care? Because trends validate long-term strategies, while anomalies act as immediate alarm bells for risk or sudden opportunity. To execute this, prompt Claude to analyze the time series data and explicitly ask it to flag outliers. In our deep dive, we must stress a critical limitation. Spotting a trend line going up does not guarantee it will continue. Claude can map the historical pattern flawlessly, but you must apply human context to realize if a seasonal factor is driving that spike. Look at how time series data is divided here. As the data passes through Claude's analysis, it isolates directional trends on the top path and anomaly spikes on the bottom. The trend path leads you to validate long-term strategy. The anomaly path demands that you investigate the immediate root cause. Claude separates the slow shifts from the sudden shocks. To get professional results, we cannot use amateur prompts. We use the perfect data analysis prompt framework. The what is a structured template that demands mathematical rigor. The basics are, never just say analyze this. That yields superficial fluff. Why? Because Claude needs boundaries to avoid hallucinating fake correlations. How do we do it? We use a specific formula. State what you tracked, define the time period, point to the dataset, and crucially, ask Claude to explicitly state the limitations of the sample size. Look at the sample prompt on the slide. By asking what additional data might strengthen these insights, you force the AI to think like a skeptical data scientist, ensuring your final insights are grounded and reliable. This mind map illustrates the anatomy of a perfect analytical prompt. At the center is our framework. It branches into 4 mandatory pillars: context, detailing the time and metric; data injection, pointing to specific CSV columns; constraints, where we demand Claude acknowledge sample size limits; and output request, asking for meaningful patterns. Miss one of these branches, and your analysis weakens. Let's apply all of this to a real-time, highly impactful use case. Meet Sarah, a coffee shop owner. She has a massive, messy CSV export of her Q3 point-of-sale data. To optimize her business, she uploads it to Claude. Using our framework, she prompts Claude to identify trends, peak hours, and day-of-week variations. Claude executes Python code over thousands of transaction rows. The outcome, Claude uncovers a hidden pattern. Pumpkin spice lattes have a massive, disproportionate sales peak specifically on Thursdays. This is actionable business intelligence. Sarah uses this exact insight to adjust her staff scheduling, putting her fastest baristas on the Thursday shift. But notice the final step, validation. She confirms this AI insight aligns with her real-world observations before finalizing the schedule. This sequence diagram maps Sarah's path to profitability. Sarah uploads the Q3 CSV to Claude. Claude internally crunches the day-of-week variables and passes the critical insight back, the Thursday peak. Sarah then applies a crucial human validation step. Once verified, the insight translates directly into business ops by optimizing the staff schedule. AI did the math, the human made the decision. Let's wrap up with the biggest pitfalls you must avoid. First, the cherry-picking problem. Do not let one exceptional sales month trick you into assuming a permanent trend. Ask Claude to verify if it's a sustainable pattern or a fluke. Second, perfect data procrastination. Stop waiting for a flawless spreadsheet. Upload the imperfect data you have today. The insights you get now beat perfect data tomorrow. Always apply the 80-20 rule. Claude does 80% of the heavy computational lifting, but your human intuition handles the final 20% of strategic decision-making. By systematically uploading CSVs, checking quality, and establishing baselines, you are now a data-driven professional. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you for watching. Our final diagram is a mind map summarizing your journey to data mastery. From the center, we branch into best practices starting with imperfect data and using structured prompts. We also map out the pitfalls to avoid, like cherry-picking outliers and blindly trusting AI without human verification. Avoiding those pitfalls and applying those practices leads directly to our ultimate goal, generating actionable intelligence from simple spreadsheets.